A new 5-year plan highlights an urgent need to develop megaprojects in space, such as human habitats and space-based solar power plants. According to Space News, a federal science agency in China is investigating the possibility of constructing ultra-large spacecraft that could span miles in orbit, citing the urgent need for this type of enormous off-Earth infrastructure. The National Natural Science Foundation of China, NSFC, an organization founded in 1986 to promote and fund scientific research, has a 5-year plan to study major strategic aerospace equipment for the future use of space resources, exploration of the mysteries of the universe, and long-term habitation in orbit, according to a recently released document. These projects could include large space telescopes, crewed spacecraft, or space-based solar power plants. In all these cases, the NSFC plan suggests prioritizing the creation of lightweight components that can be launched separately and assembled into megastructures once in orbit. This technique of in-space assembly has been most famously used with human space habitats, such as the International Space Station, which installed a new module, NACA, just last month.
The docking probe right here, this big thing, this helps us connect to the spacecraft. This probe actually sticks into this cone, and that's how the spacecraft, our Soyuz, becomes connected to the ISS initially. That is then replaced by clamps, which are around here, that will allow the two spacecraft to be stuck together. And then you can remove the probe and the cone.
China is also currently building a crewed station, Tiangong, by launching individual modules that are connected in low Earth orbit.
This is a brand new modular space station. There are many exciting things about it.
China says Tiangong will be up and running by 2022, becoming a research spacecraft that will orbit Earth alongside the nearly 23-year-old International Space Station.
Now, scientists hope to use this piece-by-piece approach to build space megaprojects on an entirely new scale. And while this sounds pretty far out, the NSFC is far from the only organization that has been looking ahead toward this goal of ultra-large spacecraft. Researchers led by Zhou Shui, a roboticist at the Chinese Academy of Sciences Shenyang Institute of Automation, recently summarized some of the efforts and possible applications of these technologies in a 2020 study published in the Chinese Journal of Aeronautics. According to Zhou Shui, with the rapid development of space technology and the increasing demand for space missions, the traditional spacecraft manufacturing, deployment and launch methods have been unable to meet existing needs. In space assembly, ISA technologies can effectively adapt to the assembly of large space structures, improve spacecraft performance, and reduce operating costs in order to create fixed structures such as space infrastructure, gas stations, space manufacturing facilities, space tourism complexes, and asteroid mining station spacecraft. Researchers at the China Academy of Space Technology are already laying the experimental groundwork to develop space-based solar power, SSP, which is a particularly ambitious and futuristic vision. Experts have speculated about solar power plants in space for decades, because they could potentially provide a renewable energy source capable of meeting the world's power needs. However, there are numerous hurdles that need to be cleared both in orbit and on Earth to make this concept a feasible energy source. USA is also working on the development of a space solar capability, and as a curious kid, it's interesting to see the development of both projects.
The experiment comes from a concept called solar power satellites, or space solar, in which the abundant and unimpeded sunlight in space, where it's brighter than anywhere on Earth, is collected and then sent to the Earth wherever it's needed.
This will be the first on-orbit test that we are aware of a space solar satellite. So the overall goal really is doing everything for the first time and proving that it works, and looking for areas that we can then improve upon this for future experiments and eventually the final system. One of the things that we would like to explore about this particular architecture is its thermal performance. It's kind of a tricky problem to have something that's in direct sunlight all the time but maintain the temperature the electronics like to operate at. So in the future, this could potentially be a groundbreaking technology for really all of society. If everything works out, this could be a major baseload power source for how we power things in the future.
Scientists based in China and the United Kingdom are also collaborating on a huge space observatory, known as the Ultra-Large Aperture On-Orbit Assembly Project, that would require robotic in-space assembly. The proposed telescope would sport a light collection area of 10 meters, larger than the 6.5-meter aperture on the James Webb Space Telescope, which will become the most sensitive telescope in space when it is launched in the coming months. In addition to these robotic spacecraft, multiple space agencies and private companies have expressed interest in working toward a future in which humans have an increased presence beyond our planet, and the blueprints for that goal are being drawn right now. Zhihui Shui said, as a human exploration of space continues to surpass Earth's orbit, the in-space manufacturing and assembly of large space structures are essential for human sustainable exploration. The NSFC plan also references the development of ultra-large spacecraft for long-term habitation in orbit, though these types of crewed megaprojects are likely decades into the future, if not centuries. Thanks for watching, stay curious.